Hello, everybody, and welcome to my class. Today we will be learning about exponents, and this is the 7th grade curriculum. So, let me introduce our schedule first. First, we are going to be doing an introduction to exponents. Some of you know what exponents are already, and some of you don't. So, let me just introduce you quickly to them, and then we'll review and we'll go over the multiplication and division properties of exponents, and those are very useful. So make sure you pay attention. And if you want, you can take notes, and it is best if you take notes because these are very important and you will use them later in many uh, mathematical subjects. And last will be solving problems. Okay, so let's begin. Are there any questions about the schedule or the topic we have uh, in this class? Are there any questions? Is there any technical difficulties? Am I not sharing my screen and that kind of stuff? No questions? Then I will continue. So, first is our introduction to exponents. So what is the definition of an exponent? So let's okay. So an exponent is a mathematical operation written as b to the nth power, okay, involving two numbers, the base b and the exponent or power n. So n is the exponent here, okay, pay attention to n, as well as the base, okay. And paying attention to the base is very important. So remember what the base is, okay? That's important. It's supposed to be b. Okay, so I'm giving you a tip here. Exponents are repeated multiplication. So let's say you have 2, which is our base. 2 would be our base here, or b, okay? And 2 to the 4th power. Now 4 is going to be n right here. That is our exponent. So 2 to the 4th power, what is that? Okay, exponents are always repeated multiplication, and I have showed you step by step on how to do this. So 2 to the 4th power is going to be 2 times 2 times 2 times 2, okay? There are 4 2's right here. Multiply 2 to itself by 4 times, okay? And what is that? That's going to be equal to 16, okay? So let's do another example. Let's say 4 to the 3rd equals, what does that equal? 4 times 4 times 4, okay? Multiply 4 by itself 3 times, okay? And that equals 64. And all these, as I've said about factorials when we were doing probability, okay, you need to remember these exponents, because usually you'll see like 4 to the 3rd, you see that a lot. 2 to the 3rd, which is 8, you also see that a lot. So it will be more helpful for you to memorize those. And then you won't have to multiply out every time. Okay, so now to check your understanding, your basic understanding of this exponents, okay, I'll give you a warm-up question, okay? So what is 5 to the 3rd power? Okay, I'll give you a few moments, okay, to figure out what 5 to the 3rd power is, okay? And please put your answer in chat. And if anybody wants to take notes on this definition and this tip right here, this tip is very important. It's going to be very helpful. Exponents are repeated multiplication. Okay, so, and you might also want to copy down example like 4 to the third, to the fourth, and also show these steps so you can clearly recall what exponents are. But for now, those who are not taking notes, please solve this warm-up question right here. 5 to the third, or in this case, 5 cubed, okay? If something's to the third power or to the second power, okay, b to the third power would be b cubed, okay? And b to the second power would be b squared. Okay, keep that in mind. So, are there any answers on this warm-up question yet? Only repeated multiplication should not be too hard. Well, 14 comments away. Okay. Jason, you're first. Very good. 25, 25, and then 125. Jason, 25 for the question on slide 4. How did you know that? Well, that is true. It is 25. Very good. But for this one, yes, it is 125. Okay? Thank you, Jason, and Ethan, Frank, Edward, Jerry, Reza. I think all of you got it correct. 125 is the correct answer. Very good. So, be 125. Okay, so for this next question, I really don't have to say it, do I? It's going to be 25. Jason already solved it for us. Very good. So our next oral question, this is a bit more complicated. So before we do that one more question, I need to explain something, okay? So aside from these numbers, all of the exponents we've seen so far are positive, okay? And I think I'll find a good way to explain this, okay? Let's erase all this, and this is going to take some explaining, but I hope my way to explain it will help you understand. So what is b to the 0th power? Okay, I want to talk about this first. So what is b to the 0th power? Now, you might think it's 0, right? But it does not equal 0. And I'll give you an explanation on that. And sometimes, always when we see b to the 0th power, and b can be any number, okay? Any real number right here, okay? Even imaginary number. Any number, okay? Could be -1, could be 2. Okay, you get the idea. It's just a variable. So any number to the 0th power is equal to 1. Okay? And why do we say that b to the 0th power equals 1? Okay, let's take this as an example. What is 2 to the 4th? That would be 2 times 2 times 2 times 2. And I already said that. That equals 16. Okay. Now, what does 2 to the 3rd equal? 2 times 2 times 2. Okay, that last 2 was pretty sad. Okay, I'm gonna redo that one. Okay, 2 times 2 times 2 equals 8. Okay? Now, what is 2 squared? Equals 2 times 2. 4. Are you beginning to see a pattern? Okay? If your exponent, let's say to the 4th power, if you just subtract 1 from the exponent, so 4 subtract 1 equals 3, then you just divide by this base, okay? What's the difference between 2 to the 4th and 2 to the 3rd? You divide by the base, because 2 to the 4th is 16. 2 to the 3rd is 8. you divide by 2. Okay, so you divide by the base each time you go down as an exponent. So that's basically our pattern here, divide by 2. Okay? And same for 2 2 cubed, 2 squared. Okay, 8 to 4, divide by 2, you get it. Okay, now let me get on with the topic. Why does b to the 0th equals 1? Okay, let's keep going actually. 2 to the first power, that's actually just the base itself because there's only 1, 2. Okay, now you see 4 divided by 2 equals 2. Each time you go down, by 1, you divide by 2, right? So 2 to the 0th power. Okay, what is the last one we did? 2 to the first power equals 2. What do? Divide by 2. 2 divided by 2 equals 1. And that is how we prove that any number b to the 0th power equals 1. Okay? Does everybody understand? Okay? Do you guys need to take notes or something? If you need to take notes, put it in the chat. Okay, no notes. You can memorize all of this. That's good. But let's keep going. After we solve 2 to the 0th power equals 1, right? There are numbers below 0. What is that? Negative numbers. Okay, so now we're going to talk about negative exponents. And you see in this oral question, we have negative exponents. So basically 0 to the negative n is going to be equal to 1 over b to the positive n. Okay, so this formula you need to memorize or take notes on. Okay, very important. Actually, both of these formulas, okay, b to the 0th equals 1. You can probably remember that, but b to the negative n equals 1 over b to the n. Okay, so how do you prove this? Let's keep going down. 2 to the negative 1. What is 1 divided by 2? It's going to be 1/2, right? So let's use our formula, actually. I can prove it with this example, but let's also see if our formula works. Okay, so our formula, b to the negative n, in this case is going to be 2 to the negative 1, equals 1 over b to the positive n. What is b? 2. What is n? It can be 1. So get 1/2. Okay, so if you don't know, you can put it in the formula for negative numbers. But if you memorize this formula, good for you. You can just quickly get the answer. So let's keep going. 2 to the negative second power. Okay. So what is 2 to the second power? That's going to be 4, right? So 1 over 4. Also, one way you can do it, you can divide 1/2 divided by 2. Okay. 1/2 divided by 2 is going to be 1/4. Let's keep going. 2 to the negative third power equals 1/8. Okay, because 2 cubed is going to be 8, so 1 over 8. And you can also do 1/4 divided by 2 equals 1/8. Okay, so now we have proven this this exponent theory. Okay, negative exponents. Okay, does everybody understand? Jason, question 2. Is 1 over a to the second times b cubed. We'll talk about that uh, later. But I'm going to inform you that your answer is correct. Congratulations, Station. You're doing very well. So, uh, does anybody else like not understand, or do I need to repeat it? I think I explained it quite clearly, but if you need any explanation, I can explain it again. So, no questions? Okay, then I will keep going. So now, our warm-up questions, okay? Jason, you've already solved this one. I want everybody else to have a chance to try and solve it, okay? So I'll give you a few moments to try and solve this practice problem or warm-up question. I don't know. These warm-up problems, okay? I'll give you a few more moments to uh, solve them. Now that you know what negative exponents are, it should be a pretty fast answer, okay? I'll give you a few moments. And please put your answer in the chat. No answers? The only one that answered was Jason and Frank. Uh, very good. Very good. That is the correct answer. Congratulations. So now let's solve. Okay, let's solve this first. This, the negative exponent, okay? When you simplify exponents, do not have a negative exponent. No, negative exponents, if you have one, it's not simplified enough. You can always simplify it. Make sure your exponents are all positive, okay? So let's solve this one. So what is a to the negative 2? Okay, 1 over a to the positive 2. Okay, and then multiplied by b cubed, okay? Shouldn't be too hard. That is going to be b cubed over a squared, okay? Any questions about that? No questions. Then I will continue to the properties. Okay, the multiplication properties, the division properties. Okay? So number 1, you're multiplying exponents. You're going to add the exponents. Okay, this is very important. Okay, as I said, please, if you cannot remember this, because there are 6 properties I want you to know, you can probably not memorize all of them and know their definitions and what to do. So it is best to take notes. Okay? So now you're multiplying exponents, okay? And you want them with the same base. Okay, all of these properties only work if they have the same base. An exception for a few, like 2 properties, okay? So remember, all of these only apply for same base, okay? So let's do a little example which will help you understand a bit more, okay? 2 to the first power equals 2. What if you multiply 2 to the first power to 2 to the first power again? And here it says add exponents, okay? It says add exponents. What do? The same base, you add the exponents. What is 1 plus 1? So 2 to the first power times 2 to the first power again. That would basically equal to 2 to the second power, right? You add the exponents. And if you actually multiply out, you'll see that's basically 2 times 2, which equals 4. Okay? So, with this, let's say what is what is a squared plus a cubed? What is a squared plus a cubed? Please put your answer in the chat. Okay, what is a squared plus a cubed? What is that? Okay, very good. Harry, Reza, and Edward. A to the fifth power. Okay, very good. Okay. So what do? A to the 2 plus 3, okay, equals A to the fifth. What is this? A to the fifth, okay? Next property we have power to a power. And let me just demonstrate. So we have a squared, okay? We have a squared in parentheses, and then a squared and cubed. What do? So what is a squared? A squared is just a squared. You can't simplify it. And we're going to, oh, what? Okay. Anyways, a squared, okay, we're going to cube a squared, okay? It's in the parentheses. We have to cube everything in it. Okay. So a squared times a squared times a squared. What is that? And remember, when you multiply, you should add the exponents. And of course, this only works with the same base. Okay, so a to the sixth power. Okay? And you might see a connection here. 6 is basically 2 times 3. And do you see the connection? And here it says multiply exponents. When you get to problems like these, you can basically just multiply the exponents there, multiply them. So this, you can say, equals a to the sixth power. You don't actually need to multiply out, okay? To prove this theory, let's try another one. B to the third, okay, times to the fourth power, okay? Basically, just multiply all of these, and what do? You add the exponents, right? So that'd be b to the 12th. And same thing, you multiply 3 and 4, okay? So now let's do a warm-up question I'm going to do a question for each of these problems that you're going to do on your own to make sure you understand these concepts because they are very important. Okay, so what is b to the negative fifth times 2? And also please simplify this. And when I say simplify, make sure there are no negatives in your answer. I just said that in a previous problem. Okay? So solve this, simplify this, okay, and put it in the chat box so I will know your answer. I'll give you a few moments. Should be a pretty quick answer. And also, I see some of you answering like this already. So on a computer, okay, usually on a computer, okay, a keyboard. Let's say you want to type in b squared, okay, what do you do on a computer? Okay, you can't type in b squared. Okay, that on a computer would be equal to b, this sign, and then 2. Actually, it'll look like this, okay? You have to have this sign. Okay. I think it's on a number, okay? You just press shift and then click the number. I think it was 6 or something. I don't know. But anyways, that's how you write an exponent on a computer. So, any answers? Okay. 1 over b to the 10th. Very good, Jason. And Edward also says it's 1 over b to the 10th. Okay. Yes. 1, not I. I figured out that. But congratulations to you guys. And Reza, I think you're missing something in your answer. Okay. It's not just b to the 10th power, it's going to be 1 over b to the 10th power. Okay, let me explain. So basically you multiply these first. So b to the negative 10th. And what do you do with negatives? And that's going to be negative n equals 1 over b to the nth. So now we're going to be doing 1 over b to the 10th. Okay. Congratulations to those who got the correct answer, and Reza, you almost got the correct answer. So very good job as well. And here we have our next property. Okay. So first, let's do product to a power. Okay. And in this one, you multiply everything in the parentheses, and you'll see what I mean by that in just a moment. Okay, let's say you have two different terms. Okay, let's say A and B. Okay, A and B are not the same. You cannot combine them. Or let's say 3B. Okay, you cannot combine numerals and variables. And that is what you learned in algebra earlier in this year. Earlier in last year. Can't believe it's 2021 already. But earlier in last year, we learned about algebra. You cannot combine those. So the simplest form would be 3b, okay? Let's say you have that in a parentheses. And then everything, okay, in that parentheses is cubed, okay? And by what I mean by multiply everything in the parentheses, I mean, okay, you have to multiply each term, okay? So 3 cubed and b cubed, okay? 3 cubed is 9, b cubed is just b cubed. So our answer will be 9b cubed, okay? Now don't write it like this because 9 and b are not together anymore. It'll just be 9b cubed, okay? Make sure cubed is on, the b is cubed, not both of them, okay? Be like this, but we write it like this, okay? So 9b cubed. Are there any questions? Are you guys taking notes? Are you guys taking notes or whatever? For those who are taking notes, if you need any time, more time to take the notes, okay. And also you might want to copy an example for those who are taking notes, okay. Please tell me if you need more time to copy these notes. But let's move on. Okay. So actually, I think it's the same with the square root, okay? So let's say you have this 3 cubed, 3b cubed, okay? This can be 3 cubed and then b cubed. Okay, what about 3b square rooted? Okay, it's the same thing. You have to square root each term. Okay? And also, I think there's okay, the space diagonal of a cube. The space diagonal of a cube is going to be 3a. It's going to be, let's say, okay, a. I've done this in a long time. A squared 2a squared, then plus another a squared. It could be 3 squared. So that is the formula for our cube space diagonal, and then we as I said, we will be square rooting everything. Okay, square root of 3 to a. That is the space diagonal, and I'm talking about geometry right now, high school geometry. You'll learn this, and you probably don't understand how I got the formula. For those who did understand, you're very smart. But that was just to prove my point. Okay. When you do something to parentheses, do it to every term, okay? Do it to every term. So now I'm going to give you a few practice problems. Okay. 3a, actually let's use ab to the 0th power. What is that? We learned this, okay? This is, you should get this in a matter of seconds. Because you barely need to solve anything in this one. What is this? It's going to be 1. Very good. Okay. Reza, what do you not understand? What do you not understand? If you don't understand the cube diagonal part, space diagonal, okay, that does not matter. It's in geometry. You'll learn it later. I think it's in high school or something. This one. You don't understand this one. It's hard. This product, this property right here, right? This property, okay? You do not understand this property? Okay, yes. You do not understand this property. Okay, so let me explain again. You need to take the power to 0 to every term, okay? A and B are different terms. Okay, right here, once you simplify it, you have to take a to the 0th power, and then you separately multiply it to b to the 0th power, okay? It's like the distributive property, okay? 3 times the product of a plus b. You have to distribute it, right? You have to distribute it. Okay, it's the same with powers, okay? So basically, this is to the 0th power, so you really don't need to talk about any or solve anything, okay, right here. It's anything to 0th power is going to be equal to 1, okay? So now let's go to dividing exponents, okay? Now, all of those, you might see that, look at this. All of these are about multiplying. Now let's go to the division properties of our exponents, okay? What about the division properties? We're missing on those, okay? So now, our 4th, 5th, and 6th properties are going to be about division, okay? So, dividing exponents. You remember multiplying exponents, what do? We add exponents. But dividing exponents, what do? We subtract exponents. Okay, so a squared divided by, okay, a squared divided by a to the first would equal to a to the first because 2 minus 1, okay? So it's very straightforward, okay? And if you want to prove this, then you can easily prove it. So now, what is a to the fourth divided by a to the second, okay? Give me an answer, should be a matter of seconds, okay? So what is the answer? A to the second. Very good. So, very good. A to the second power. You guys are doing very well. So now that was pretty straightforward, and this is also pretty straightforward. But our sixth property, it might need a bit of explaining, and there's a formula for that as well. Okay, so make sure you take notes during these properties. So our fifth property, what is that? That is going to be quotient to a power. Okay, the same thing as product to a power. Okay, product to a power, multiply everything in parentheses. Quotient to a power, same thing. What do you have here? 2x over, let's say 2x over 3 or something like that. Okay, multiply everything. Okay, multiply everything. Okay, so let's say that's to the third. Okay, multiply everything. What is 2 to the third power? What is x to the third power? Okay, what is 3 to the third power? It's like the distributive property. Okay, so let's do it. 2 to the third power. It's going to be 8 times x to the third power over 3 to the third power, which is going to be 27. And here is the simplified version of it all. Okay? So does everybody understand this quotient to a power? This should be quite easy because we've done, product to a power. What is this? Yes, our third property, product to a power. Okay, multiply everything in parentheses. See? And most of these properties basically pretty similar, division and multiplication. Okay? Okay? Very good, Reza. So now let's go to, actually let's do a practice problem on this one first. So a b over 2. Okay, let's do that. Let's do the fourth power. Okay, I'll give you a few moments to try and solve this one. Okay, and put your answer in the chat. AB to the fourth over 16. And Reza disagrees. A to the fourth power and then b to the fourth power to 16. And Reza, your answer is correct. Frank, you're missing something. So remember, multiply a and b and 2. Okay, Frank, you forgot to raise a to the fourth power. So remember, don't forget a. Okay, that will be our answer right here. So our last property, and this is a bit more complicated. So quotient to a negative power, it's going to be the same as our last one, but negative. Okay, and this is going to be a bit harder because negative powers, you have to flip everything, right? So now let's do it. Okay, so let's just do one of the most simplest, okay, examples. If we do it too hard, okay, too complicated, it might be hard to to understand, okay? So just AB over 1, okay? And actually, let's make it 2 because AB over 1 is basically just AB, and that defeats the purpose. 2. Okay, AB over 2. Now, what do we do here? To the negative 1. Remember, still distributive property, and then we'll talk. So, let's do it. A to the negative first power is going to be 1 over A. And what about B? It's going to be times 1 over B. That's basically 1 over AB. Don't forget the next part, right? What do we do? Okay, it's divided by 2 to the negative 1. What is 2 to the negative 1? It's going to be 1/2. Now we divide it. And what do you do when you divide fractions? You multiply by the reciprocal. That is where the flipping part comes in. Comes in mind, okay? So 1AB times 2 over 1. It's going to be 2 over AB. And this is pretty peculiar because you see, we flipped the whole thing. Okay, it started out as AB over 2, right? Now we have 2 over AB. And then we multiply by the positive exponent. That'll just still be 2 over AB. And an easier way of doing this, okay, let's derive the formula actually first. So A, B over C to the negative nth power equals C over AB to the nth power, to the positive nth power. Okay, that is our formula. And you see here, I even wrote out a little tip for you, okay? So what does it say here? Flip and multiply by the positive exponent. Actually raise up to the positive exponent. So flip the whole thing in the parentheses, okay, and multiply by the positive exponent. And that will be very helpful when you're solving problems like these, okay? Actually, let me introduce you to another problem. Okay, so what is 2c over b raised up to the negative third power? What is that? I'll give you a few moments to put it in the chat. Okay? So, Jerry says b over 2c to the third power, okay? You forgot the parentheses, but I'm sure you thought of the parentheses, so very good, Jerry. Correct answer. And Jason, same thing. Parentheses, very good, very good. So that indeed will be this. Okay, and sometimes specific problems, they might want you to do this, might want you to do this, but sometimes they want you to put it in this form. And what is this form? This is called exponent form. Exponent form, okay? And this is where there's an exponent, you don't actually solve with exponent. For example, this would also be exponent form. Now let's start doing problems. This first one, matter of seconds. Okay, get it done. Matter of seconds. First problem, practice problems. These are actually practice problems, okay? Don't let this complicated problem fool you. Pay attention to the last exponent. should be pretty quick, okay? I expect everybody who's been paying attention and not secretly playing video games on another tab to give me an answer, okay? I've talked about this concept before earlier in this lesson, uh, and I expect an answer, okay? 1. Very good. Jason, Edward, Jerry, Gemina, and Jason again. How do you know the next one? Wow. And that also is the correct answer for the next one. I don't know how you know the next one, but okay. But 1111 is the answer. Oh, you have the entire slide. So, oh wait, yeah, it was put in recap. That was pretty dumb for me. Okay, yeah, the next problem, of course. So, anyways, Jason, you seem pretty familiar with exponents, so good for you. You've done excellent in this class. So, of course, anything to the 0th power equals 1. Okay? Don't let this very complicated, seemingly complicated problem fool you. It's just 1. Okay? Number 2. Was this 4 to the 7th, and then to the cubed, and then 4 to the negative 9 squared. Okay? And I think I didn't say it properly, but I think you get the idea. It's written on the slide. So I'll give you a few moments to try and solve what is this, put it in the chat box. This one, I'll give you more time to do this one. Remember, I think we're using two multiplication properties. Okay? And actually, bonus question. If you can tell me which 2 multiplication properties we're using here. Okay, that's a bonus. Okay, if you can figure out which are the 2 multiplication properties, that is a bonus. Okay, but for now, I expect everyone to give me an answer. Okay, what is this? Okay, and you don't need to actually simplify it to numbers, just write it in exponent form. Or is it exponential form? I don't know, but it's something similar. Exponent form. Okay, just put it in exponent form. I'm not going to tell you to actually simplify it to numbers. Sometimes it's going to be a very long number. Just put it in exponent form. And also, if you paid attention or take notes during multiplication properties, you might want to get this bonus right here. Okay, tell me the 2 multiplication properties used. Okay. Wow, Jason. Y to the 10th power, 48 to the 48x to the 6th power. I think that's pretty much correct. So anyways, Jerry says 4 to the 3rd. Very good. And also Reza says 4 to the 3rd. Jason, power to the power. Okay, you're going to get the bonus, I see. Power to the power, okay? That is correct. You multiply the powers, right? And the one where you flip the thing. Are you sure we're doing any flipping right here? Are you sure we're doing any flipping? Let me explain, okay? So let's just multiply both these exponents right here. Okay? Yes, we did. Your first answer is correct. Okay. Oh, and the multiplication property. Very good. You add the exponents. Is that correct? You add the exponents. And what is negative 18 plus 21? 24 to the third. Okay. And it's in exponent form. If you really want to simplify it, it's going to be 64. Congratulations, Jason, for figuring out the two multiplication properties in addition to figuring out the answer. Very good. Next one. Don't let this fool you. This is actually pretty easy. Okay? I'll give you a few more moments to solve this. Actually, more than a few moments. This, you might want to recheck your work. Jason, actually, let me solve it mentally first. That'll take like 1 minute, or less, 30 seconds. I don't know. And let me check if Jason's answer is correct. Let me just solve this mentally first. And everybody else, either you take notes or you're going to do this problem, okay? This is pretty hard. Some of you might not know this, okay? But please give me an answer. Okay, let's see, what is this? Okay, I solved the problem. Pretty easy one. Okay. Jason, I think you're wrong. Yeah. Y to the 10th power and 48x to the 6th power. Are you sure? 48x, huh? 48x. Hmm. So, now that you found your mistake, can you give me the correct answer now? You have to minus with the y? Are you sure about that? What do you do when you minus a negative? What is that? It's still y to the 10th. That's not your mistake. Your mistake is elsewhere. Let me remind you that you are dividing, not multiplying. 4x times 12x. Yes, that is 48x. And then some exponent. We are dividing here. It's going to be 1/3. And then x, -5. Okay? So I think I found your mistake. Now let me actually properly explain this. First, what do we do? What do we do? So many numbers. Very scary, huh? What you do here is you want to see this as each term for itself. Okay. Okay. So I've basically simplified it now. So what is 4 divided by 12? It's gonna be 1/3. It's gonna be 1/3. And then what is x? Okay. X to the negative second to x to the negative to the third. Okay. You subtract, right? That'd be x to the negative fifth. Now x right here is to a negative exponent. When you simplify, no negatives. So simplify first. It can be 1 over x to the fifth. You can simplify this as 3x to the fifth. Now, what is y? I already solved that y is going to be equal to y to the 10th power. Now we just multiply, right? That is going to be equal to y to the 10th over 3x to the 5th. And as I said, Jason, you might have wanted to recheck your answer on this one. And raise that as well. Okay, make sure you are actually dividing, okay, not multiplying. But you guys did get partially correct. The y to the 10th you didn't get correct, but you said 48, which is not correct, and I think you also said 48x to the 6th power. Okay, it's to the 5th power. And I think I know why you said to the 6th power, because see here, 2 times 3 right here might have been the reason. But I said, please remember your properties, because I think this uses a lot of different properties. Okay, here's one, power to power. Here's another one, just the whole thing, dividing, right? Dividing, okay. And that's dividing, and what else is there? I think there's only 2. Is there any multiplication properties right here? There is this power to power one, but I don't think there are only 2. I think, okay. But this is the full simplified version. Okay, does everybody understand? Jason, do you understand now? Okay, Reza, do you understand your mistake? Okay, you understand your mistake? Okay, yes, very good. So, that was our last problem. Thank you for listening, everyone. And please like this video and subscribe to my channel, though I doubt anyone is good enough to survive to the end of this very boring video. But anyways, turn on notifications so you never miss out another video. Wow, one of the most cliche YouTube lines. Wow, can't believe I'm saying this. But thank you for listening, everyone. And see you next time.